This video tutorial presents a generic experimental procedure. Please consult your class notes for term-specific instructions. Here's an Aerolab wind tunnel with the air intake funnel on the far right. The test region has an 8-inch cross-section with bilateral access doors. The adjacent panel controls a blower motor with wind speeds up to 65 miles an hour. LabVIEW is utilized to measure the lift and drag forces on the test specimen. Open the LabVIEW shortcut folder and select Wind Tunnel Main. Once the LabVIEW program opens, navigate to the Configuration tab. The test duration defaults to 2 seconds with a sampling rate of 200 Hz. These are the only parameters you may need to edit. The force transducers must first be calibrated to convert the raw voltage signal into a meaningful unit of force. Mount a balsa wood block in the test section using a threaded sting. Gently snug the set screw to secure in place. Now start LabVIEW, then click the null button to balance and/or zero out both load cells. Select a calibrated weight and place on top of the wood block to apply a known downward force, or negative lift. In LabVIEW, press the green Take Data button to start the test. After a few seconds, LabVIEW will present a statistical summary of the raw voltage signal. You may save the results to a data file by pressing the Save Data button, or simply record in your notebook. Here's a sample listing of a data file with a statistical summary in the header and the time-dependent values of lift and drag in columns. Remove the weight and return to the plastic storage bin. With the block unloaded, null the load cells and then repeat this process with varying loads. Plot the voltage signal as a function of applied load and use the slope as a conversion factor in future calculations. We'll be using the Corex force gauge to calibrate the drag load cell. Note the units of force is in centinewtons. Always position the feeler arm at right angles to the direction of load by slightly rotating the gauge with increasing load. Have a team member apply a static lateral load to the sting. In LabVIEW, click the Take Data button. When finished, record or save the results. Repeat this process at varying loads and in both directions, i.e. positive and negative drag. You should null the load cells in between each test. As before, you'll construct a plot of sensor voltage versus applied load and use the slope as a conversion factor. When finished, please return the Corex and any tools to the storage box. Airspeed is measured using a manometer and Bernoulli's equation. The manometer must first be leveled using the thumb screw and monitoring the sight glass. Once leveled, use the lower white knob to adjust the meniscus position to 0. Be sure to record the environmental conditions of the lab. Typically, a wooden block is shaped to meet a certain objective. The adjacent conference room contains some basic tools to shape the block. Please keep this door closed to prevent dust contamination. A scroll saw may be used for rough cutting. Please operate with caution. Use sandpaper for fine shaping. All sanding should be conducted over the downdraft table to mitigate dust. Masks and earplugs are recommended. When finished, return to the lab. You're ready to conduct wind tunnel testing. On the workbench, install the threaded sting into the pre-drilled hole of your shaped wooden block and secure with a washer and nut. Mount the entire assembly into the wind tunnel, gently snug the set screw, and close the door. Use the lower switch to turn the power on. In LabVIEW, once again, null the load cells with the blower motor off. Toggle the middle switch to run position and use the top knob to adjust wind speed. The digital display is an approximate wind speed. Always use the manometer to determine actual wind speed. Return to LabVIEW and click the Take Data button. When finished, save and/or record the lift and drag results. Toggle the middle switch to stop to turn the blower motor off. In a nutshell, null the load cells, start the blower motor and set the wind speed, then run the LabVIEW test, stop the blower motor, and record the results. Repeat this process at several wind speeds. Next, you'll need to determine the contribution of the sting on drag force. Mount the short sting in the wind tunnel. Measure the drag at each of the previous wind speeds and negate the calculated force from your previous results. If you experience an error or the results seem odd, the problem is usually the magnetic connection rod, which prevents the load cell from being overloaded. Simply reattach over the spherical ends and it snaps into place. Remember to save your data before leaving the lab today.